Welcome back. This is Sean from Tech Train Solutions here with Basic Electrical 101, voltage. Voltage is the driving force behind electricity. This is what drives our world. This is what gives us energy, able to watch our TVs, able to charge our phones, able to drive our electrical vehicles. Voltage is the push that gives us light and makes those machines work, that gives you the products that you use today. Voltage, the driving force behind electricity. A deep dive into electrical potential. What is voltage? Voltage is simply the difference in electrical potential between 2 points. So think of water and the pressure in the water. So as, let's say, a regular garden hose, you turn on the faucet, the water coming out, that push of that water is voltage. No matter if I slow down, but start slowing to turn off the water, I still got the same pressure. The flow is just lower. The pressure will always be there from the utility turning the pumps on, giving that water. The pressure will always maintain the same. Same thing with electricity. That force will always be there. You always have 120 volts, 240 come from the power company. That is force. So what I'm going to talk about now is units of measurements. Voltage is measured in volts represented by the letter V. To measure voltage, you need a voltmeter. To understand the difference in potential, you need two different difference in potential. If you go to the same source, you won't see anything. There was a time I was working side work, and it was knob and tubing. I'm up there. I'm young. I get my tick tracer, voltage indicator. I see something. I'm just thinking it's a false. So I pull the wire. I get hit. I'm like, oh, my goodness. So I decided, let me think. There's no ground here because it's knob and tubing, and they don't have a neutral there, I'm assuming. So I got an extension cord, ran it up to me, used a neutral from the extension cord, tested at 120 volts. 120 volts. Reason I didn't see it, because I didn't have any neutral or ground in that box. You need to see a difference in potential. Either DC, you need to see positive and negative, or 120, or AC, you need 120 volts to a neutral or the white wire, 120 volts to another 120 volts, which will give you 240, or 120 volts to ground. You need some sort of difference in potential to see. As you've seen, that was a visual representation of voltage in action. This was showing you the difference in potential. In the beginning, it was DC. You put batteries in series with each other, 1.5 volts. You add them together, that was 6 volts. That's the difference in potential. Then I saw the electrical panel, right? Single phase to ground, you got 120 volts. If you did 3 phases, it's 240 volts between the phases, cause the difference in potential. Now I want to talk about the science behind voltage. This is the scientific side. Voltage relates to the electrical energy potential, the work per unit charge. The formula is simple. Voltage equals work divided by charge. Work is measured in joules and charge is measured in coulombs. So what's that mean? Basically work, which is joules, right? It's a layman's term, which we'll talk about in a minute. Those two will give you the voltage. So what is joules? Joules is the standard unit of energy, international system of units. It measures 1 joule equals the energy required to apply force on 1 Newton over a distance of 1 meter. In electrical terms, 1 joule is the energy used when 1 watt of power is consumed for 1 second. I'll give you an example. Lifting up an apple 1 meter takes about 1 joule. A 60-watt lamp in your house uses 60 joules every second, uses 60 joules. So that 60-watt lamp is consistently using 60 joules every second as you leave that fixture on, right? So that's what I wanted to show you is the scientific side. But now I want to talk about the different types of voltage. The main ones basically is alternating current and direct current. DC is used in many different locations. Your flashlights, your electric cars, your electrical battery for your car. But first, I want to talk about DC more in depth. Direct current flows in one direction, just from positive to negative, going from positive over to negative. There's no difference in potential as it moves. Common sources, again, is AAA battery renewable systems, AA batteries, solar panels, your car battery, lithium ion batteries, and many more. So let's look. As you see the line moving, DC is moving from positive to negative. The car cannot run without a battery. It needs that battery to run. As you see in that picture, you had car batteries. They're the things that run on DC. Now I want to talk about alternating current. Alternating current is positive and negative the whole time. It rotates. It's called hertz. 60 hertz is 60 cycles per second. That's hertz. It's a type of electricity we use everywhere at homes, factories, stores. It powers our lives. Without AC power, we are not able to charge our phones. We're not able to turn the lights on, not able to cook with our electrical heaters, not able to power our homes with basic essentials that we have today. AC is what gives us that because it helps. We give really big voltage in our power plants and send it to you in a usable voltage. That is AC. Let's go show an example of it. AC flows from positive to negative every 60 hertz per second. That is AC. That was showing us how AC runs is negative, alternates, right? 60 hertz, which is 60 times per second. In Europe, they use 50 hertz, and they're 50 hertz 220. We're 60 hertz 120 240. That is alternating current. But how do you produce alternating current? What's happening? Well, easy. You have your generator at home, right? The one that when you lose power, that's generating AC voltage. That's applying you power when you have power outages. Utilities will use power plants to the right. This one is showing a nuclear power plant, but you also have coal power plants. And in the middle, that's the turbine that's in those power plants, rotating at a very fast speed, providing us electricity to the whole nation. This is what gives us power. It's power in the cities and our world. That's what I want to show you. Now let's talk about the math behind the voltage, right? This is more for us electricians. This is not science, more like the math. This, you have ohms and power or watts law. Ohm's law is showing the relationship between amps and resistance. That's pretty much telling me volts. As long as my volts stay the same, my resistance, if it goes down, I have more amps. If it goes up, I have less amps. Voltage, if my voltage goes up, I have more amps. My voltage go down, I have less amps. Watts, now the Watts law, that's power. Power is telling me my volts times my amps gives me Y watts. My watts is basically the end goal of electricity. It's what's being used or produced at the end goal. That's how we determine our electrical usage in our house. That's where we get our bill from, is from wattage. You'll see power ratings on appliances, 240 volts, says 5,500 watts, or your toaster, 1,200 watts, or your iron, your hair dryer, you're using it, trips the circuit, maybe because you have too many watts in the system. So that's basically what is telling me my voltage, my amperage gives me watts. Now let's talk about the different levels of AC voltage. Power companies use high voltage lines, up to 765,000 volts. Those really tall power lines you're seeing, that's how much is up there. That's the voltage. What helps out though, being that such high voltage, copper at long distances, it adds resistance. So higher voltage, you have less resistance. That means you have less power loss. It moves electricity efficiently. Substations then, that's those things you're driving down, you see them gated around your neighborhood. Those substations, the ones gated around your neighborhood, those substations now drop that voltage to a utility usage voltage like 13,000 volts or 35,000 volts. It'll drop it down, and then what happens is now probably put on power lines and drop it down one more time for us, the customer, right? You'll see the transformers and the poles. That one will drop it down to 120 to 240 volts for the home or the business. Home, business, and industry uses about 120, 208, or 240. Now, the difference is businesses will use something called 277 480 along with industry. 277 480 is called the holding voltage. It holds you, and you be screaming, and you won't be saying nothing because you're being held. Now, some industry will use 575 volts, 600 volts, or 2,300 volts. Why is industry using such high voltage? Well, they got these big motors the size of this room or this house. Those big motors need to move. The only way to move them is have the voltage as high as possible. 2300 volts is a problem though, because you can't test it properly. Meters only go to 1,000. That is the difference in utilities. So let's move on to DC voltage. DC voltages of DC, they vary from 1.5, 12 volts, 24 volts. Lithium ion can vary from 6 volts up to 48 volts or 68 volts. Voltage will also depend on application, on the equipment being made. But in industry, you have something called control voltage, which is 24 volts. Instead of using 120, 240, which is considered unsafe, 50 volts and less is considered safe. 50 volts and above is safe, unsafe. So 50 volts and down, you use 24 volts for controls to start and stop systems. You also use 24 volts for something called instrumentation. The instruments have varied signal that gives you an idea where it's at. Then you have other control voltages like 5 volts, 10 volts. It's like 0 to 10 volts. 0 is a machine or the equipment's 0, or 10 volts could be full speed, and then 5 volts is middle speed. They're the different voltages that we use in industry. So what I'm going to do is show a closing image. We use electricity everywhere between charging cell phones, lights for our light show and concerts, and also for charging our vehicles. It is everywhere. Voltage is the push. Remember, this is the push. But stay tuned for the next episode. That'd be Basic Electrical 102, where we talk about ampacity or current. So stay tuned. My name is Sean Quinn from Tech Train Solutions. I thank you for showing and watching my video. Please subscribe, contact me. Let me know what else you want to hear. Thank you. Have a good day.